So when we think about kinetic molecular theory, if we think about a thermometer, this basically explains that as the temperature increases, the particles move faster and faster and faster. And at the very bottom of our thermometer, we're going to have 0 Kelvin, which is absolute zero. And absolute zero, basically what it means is, at this point, all movement ceases. We've never gotten down to absolute zero, but theoretically, this is what scientists believe will happen. At cold temperatures, we're going to have, our particles are going to be a solid. As you increase the temperature, they're going to be moving faster. So as the temperature increases, the speed of the particles increase. And you go from a solid to a liquid to a gas. Okay. Kinetic molecular theory, warm particles move faster. Now, when we're talking about gases, we don't care about solid, we don't care about liquids right now, we just care about the gas phase. And in a gas, we have this concept that is called a concept of an ideal gas. And an ideal gas, all that means is that it is a theoretical situation. Ideal gases don't exist. They should, but they don't. An ideal gas has 3 criteria. Number 1, it has no volume, because the particles keep expanding. They keep moving out and they keep moving out. So an ideal gas just keeps expanding. Secondly, there are no attractive forces between the particles. What does this mean? When one gas molecule or atom hits another gas atom, its energy is transferred. They don't stick. They don't stick together like a magnet. There's nothing that's going to keep them together. So they have completely elastic collisions, which means you've seen that thing in maybe some doctor's office where you have all those metal balls on a string, and then you have one ball and you pull it up and you move it, and then this one flies out and that one flies out. It's transferring the energy between the balls. This is kind of what's happening in ideal gas particles when they're colliding. And the third criteria for ideal gas law is that they move in a straight line. So they're constantly moving in a straight line until they hit something else. So basically a gas particle is going to move until it hits another particle or until it hits the side of the container. Now again, ideal gas law. Number 1, has no volume, it just keeps expanding. Number 2, there's no attractive forces between the particles. Number 3, it moves in a straight line until it hits something. Now this only exists under 2 situations. Under extremely high temperature, because you want the temperature to be really high so the particles are moving really, really fast so they can keep expanding. High temperature and also low pressure. Because of this low pressure, it means that it can keep expanding because it has no volume. So if there's pressure pushing back on it, it cannot expand. So in order to be an ideal gas or behave like an ideal gas, it needs to be under high temperature, low pressure. There's a ton of questions on this. In the practice, there's a ton of them like this on the Regents. Okay? And the last thing that I wanted to add is that, let me erase this. When you have one mole of a gas, whether that gas is neon, argon, oxygen, hydrogen, or even something like ammonia gas. Regardless of the number of atoms, 1 mole of a gas is 22.4 liters, always. And this is because of the behavior of the gas particles. The size of the particle is negligible to the space of the gas. So whether you have neon, which could be 1 little dot, argon, 1 little dot, oxygen is 2 little dots, hydrogen, 2 little dots, ammonia can be 4 little dots. In the grand scheme of things, when in a gas sample, they're so far apart from each other that the size of these doesn't really matter. Okay? You're going to look at the practice problem right here. Good luck.